and line Q which are on a plane. The lines are also parallel to each other, which would mean that they do not intersect or ever meet. And this is transversal R, which cuts the lines P and Q at two distinct points. In this video, we will try to understand the different types of angles formed by the transversal with two parallel lines. The transversal forms four angles with line P. Angles 1, 2, 3 and 4, and four angles with line Q. Angles 5, 6, 7 and 8. Let's move on to the first type of angles. If lines P and Q are parallel, then angle 1 will always equal angle 5. This angle here will be equal to this one. They are called corresponding angles. It doesn't matter how the transversal is placed. These angles will always be equal. On a new page, let us try moving the transversal around. Assume line A and line B are parallel to each other. And here's the transversal C. You can see that these two angles look equal. Now let's rotate the transversal towards the right. These two angles again seem to be equal. Now let's rotate the transversal towards the left. The angles become obtuse and are still equal. This tells us that the corresponding angles are always equal. Now let's go back to the previous page. Now let me ask you an interesting question. Look at the figure closely. Is this the only pair of corresponding angles? No, it isn't. We have three more pairs of corresponding angles. When a transversal intersects a pair of parallel lines, four pairs of corresponding angles are formed. 2 and 6 form a corresponding angles pair, so angle 2 will always equal angle 6. You can even look at the figure and observe that they are equal. Similarly, angle 3 will equal angle 7 and angle 4 will equal angle 8. These are the four pairs of corresponding angles that are formed. 1 and 5, 2 and 6, 3 and 7, 4 and 8. Angles 3, 4, 5 and 6 are interior angles because they are between the two parallel lines, and they are classified into two types. Let's understand the first type. Angle 3 and angle 5 form a pair of alternate interior angles. We know why they are called interior, but why exactly are they called alternate? If we have a round table with numbers 3, 4, 5 and 6 around it, then 5 is alternate to 3. That's because after 3, you skip one position and take the next. Similarly, 6 will be alternate to 4. In this diagram as well, to find alternate of 3, we skip one position and take the next, which is 5. And similarly, angle 4 and angle 6 are also called alternate interior angles. This was the first type of interior angles. The second type is a pair in which the angles are next to each other on the same side of the transversal, like angle 3 and angle 6. They are called consecutive interior angles. Look at the figure now. Do you see any other pair of consecutive interior angles? Yes, with the same logic, even angles 4 and 5 are consecutive interior angles. Remember, there are two types of interior angles, alternate and consecutive. For alternate, we skip one and move to the next. For consecutive, we take the one that's immediately next to it. And the last types of angles that are formed are vertically opposite angles. Angles 1 and 3 are called vertically opposite angles. In all, there are four pairs of vertically opposite angles. Apart from angles 1 and 3, we have angles 2 and 4, angles 5 and 7, and angles 6 and 8 as the other three pairs. And vertically opposite angles are always equal. These were the different types of angles that were formed when a transversal meets two parallel lines. On a new page, let's look at the beauty of these angles. Assume we have lines A and B which are parallel and transversal C which intersects them at two distinct points. As we already know, the transversal forms 8 angles. 1, 2, 3, 4, 5, 6, 7 and 8. Let us quickly analyze the relation between various angles formed. It's pretty simple actually. Angle 2 will be equal to angle 6 as their corresponding angles, and angle 8 equals angle 6 as it is vertically opposite to it, and angle 4 equals angle 8 because they are corresponding angles. Similarly, angle 1 equals angle 5 as their corresponding angles. Angle 7 equals angle 5 because they are vertically opposite. And angle 3 equals angle 7 because they are corresponding angles. So if lines A and B are parallel, we can see that angles 1, 3, 5 and 7 are equal and angles 2, 4, 6 and 8 are equal.